Hello, my triglets. How are you today? Hope you're doing well. Today we're going to do section 3.6. This will be our last section before we take our first big test. We're going to talk about special angles. And these are some that you've seen before. Special angles are like on the axes and the 30s, 60, 90s, and the 45, 45, 90s. So those are ones that we've, well, you've seen 30, 60, 90s before. Let's do a quick recap here. If this is a 30, we got 60 up here. The short side is x, hypotenuse is 2x, and this side is root 3x. 45, 45, 90. We have x to x to x root 2. So just remember those when we start talking about the trig parts of these. Now, let's go to the new clean page. Here's my circle. And if I am on the axis here, remember that sine of any angle is y over r, and cosine of any angle is x over r. If I have a picture drawn or a triangle drawn on the x-axis, I really can't draw a triangle. It's just a flat line because there's no height to it. So the radius and the x actually are the same because my x value and my radius are the same line. So if you think about that, come over to here, no matter what it is, if these are going to be the same, it's always going to reduce to 1. So we say that the cosine of 2 pi equals 1 because that's what x over r is. Now the sine of 2 pi right here is 2 pi. There is no y value. There's no up or down movement to get to a, make a triangle. So there is no y movement. So it's y or 0 over r, which is y over r. So we just say the sine of 2 pi is 0. And that's always going to be the case. It's zeros or ones. So every corner, if circles can't really have corners, but I think you know what I mean. Every corner is either going to be a 0 or a 1. Now, if you think of just plotting a point, and I go this way 1 and up 0, I could plot that point as 1, 0. And 1, 0, this is the cosine, this is the sine. So if I go up here, if I plotted that point, I went 0 to the right and up 1. This is cosine, this is sine. Now what would it be over here? If I'm going to the left, but not up any, this would be -1 and 0. Down here, I bet you could fill this in now. You're going straight down, you're not going to the right, so you go 0 to the right and down 1. And it's always 1 because of what I talked about here, how r and x are always going to be the same. When you're looking at this side, then r and y are going to be the same. So it doesn't matter what they start out, they could both be 5s, but it's always going to reduce down to a 1. So far we have this. Now let's figure out the other one, sine and cosine. What about tangent of 2 pi? Tangent, remember, is sine over cosine. So if I take the sine from this answer and the cosine from this answer, I get 0 over 1, which is 0. Now about the evil twins. Cosecant of 2 pi. Now think of up here, go up here, because secant or cosecant is the reciprocal of sine. Think of this as 0 over 1. And if you flip 0 over 1, I get 1 over 0, but you can't divide by 0, so we say that this is undefined. There is no such thing as the cosecant at 2 pi. It doesn't work. Secant of 2 pi, if I flip over cosine, think of this as 1 over 1. Flipping 1 over 1 is still 1 over 1, so the answer is just 1. and then cotangent of 2 pi. Flipping over this, I get 1 over 0, which again is undefined. So we have a lot of different answers here, but they're all zeros and ones, and then we throw in a couple undefines when we start flipping things over. All right, so that's on the axes. Let's go to 30, 60, 90 triangle. Let's draw one in the first quadrant here. So let's do the ratio of this side is x. We'll just call it 1. That makes this side 2. That makes this side root 3. Okay, just as a reminder, this is x, this is 2x, and this is x root 3. So if I make x 1 to start with, then it just comes out 1, 2, and root 3. So if I want the cosine, now this is 30 degrees. So cosine of 30 degrees is x over r. What's your x value? X value is this line right here. And we just said that was root 3. And then the r value is this side right here. And we just said that was 2. So root 3 over 2. All right, let's go back and do the sine of 30. Sine of 30 is y over r. Y is this value, which is 1. And r, we already said, was 2. So it's 1/2. Now the rest we just do by using sine and cosine. Tangent, remember, is sine over cosine. So it is 1/2 over root 3 over 2. If the 2's are on the bottom, there's a shortcut where you can just cancel out the 2's, or you think invert and multiply. 2 over 3, root 3. Now the 2's cancel. I get 1 over root 3. And of course, you got to get the radical out of the bottom, so you get root 3 over 3. Okay, let's go to secant. Secant is 1 over the cosine. This is cosine. Flip it over, I get 2 over root 3. Get the radical out of the bottom. I'm left with 2 root 3 over 3. And then cosecant. Cosecant is flipping the sign over, the evil twin, so I get 2 over 1, which is just plain old 2. So we have all our answers up. One more I got to do, cotangent. Cotangent of 30. Let me make that a little neater here. Cotangent of 30. Now we look at tangent. So I'm going to flip these two over. I'm going to say root 3 over 2 over 1/2. Now you can do the invert and multiply like I did before. I like the shortcut if the denominators are the same, you just get rid of those. Root 3 over 1 is just root 3. Only if it's denominators. You can't cancel them out if they're numerators. It doesn't work that way. So root 3 over 2, 1/2. And then all the other ones stem from that. All right, let's look at 45, 45, 90. Nope, I'm going to back up. Hang on, let's do something else here. Let's do the circle. And 45, 45, 90 would look something like that. It's a 1 to root 2. Oops, root 2, not 3. So if I have sine of 45, again, it's y over r. Y is your 1. R is your root 2. So 1 over root 2. I don't know why I keep writing a 3. 1 over root 2. Get your radical out of the bottom. So it's root 2 over 2. Cosine of 45 is x over r. You're going to get the exact same thing, 1 over root 2. So now I know it's root 2 over 2. Tangent is going to be sine over cosine. Well, we have a number over itself, so it's going to reduce down to 1. Or you can think, all right, I'm going to cancel that and that. And so 1 over 1 is 1. And all right, now we got to flip them all over. So I'm going to start with cosecant of 45. Flip over 1 over root 2, so root 2 over 1, so just root 2. Secant is easy. It's the same exact thing. We're going to get root 2. Cotangent of 45, we're going to flip over 1. Well, 1 over 1 is still 1. So anytime you have a 30, 60, 90, or a 45, 45, 90, these are the answers you're going to get. You're going to always get root 2's. You're always going to get 1's for these. Root 2 over 2's, root 2 over 2's. The only difference is maybe if I'm in the second quadrant, I have a negative here, and so that's on the x-axis. So that means x over r is going to be negative 1 over root 2. So I would get negative root 2 over 2. So the only difference is depending on what quadrant you're in, if the sign is going to change, the plus or minus sign. Let's do a couple examples. If I have 225 degrees, I want you to find sine, cosine, and tangent. All right, 225, that ends in a 5. That makes me think it's probably going to be a 45. Let's double check. Look on your circle, find 225. It's right here, 225 degrees. That's a 45. This is negative, this is negative. This is always going to be positive. So everything's going to be still root 2 over 2's. Sine is still root 2 over 2, but it's negative. Cosine is root 2 over 2, but it's negative. Tangent is still 1, and because both of these are negative, dividing two negatives, this is going to be positive. So it doesn't matter what quadrant it's in, it's always going to be root 2 over 2's and a 1 for sine, cosine, tangent on a 45. It's just the plus or minus signs that you got to be careful of. Let's try another one. Negative 7 pi over 3. Now, technically it's not on the circle that we drew, but because it's thirds, those are always 60-degree angles. So let's look at this, find out what quadrant we're in. If we're negative, we're going to be going down. So I'm going to count thirds. Every 60 degrees is a third. There's a 60, there's 60 more, then I'm right on here, 60 more. So all the way around would be 6 thirds, because 6 thirds is 2, and so all the way around is 2 pi. So let's count. Here's 1 third, 2 thirds, 3 thirds, 4 thirds, 5 thirds, 6 thirds, go one more, and I'm at 7 thirds, negative 7 thirds. So if I draw the triangle in there, this is 1, this is 2, this is root 3. This is positive, right? This is negative, down. So if I want the cosine, the sine, and the tangent, the cosine of a 60-degree angle is x over r. So that's 1 over 2. The sine would be y over r, so negative root 3 over 2. Tangent is sine over cosine, so it's negative root 3 over 2 over 1/2. 2's cancel, you're left with negative root 3. Now if you go back and look, we did a 30-degree. These are all going to be opposite of 30-degree angle. Those are going to be switched, and tangent and cotangent will be switched too. So you just have to, you know, make sure you draw it correctly, and then draw in the 1, 2, and the root 3, and you got it figured out. Now, one other little quick thing here. They're going to talk about a reference triangle. Reference triangle means the triangle you draw, okay, to find the answer. Now, for instance, if I said 225, we knew that that was here, but my reference triangle is a 45. So the reference triangle there is a 45 degree. So it's whatever angle is in here is your reference angle, and the triangle is the one that you draw. Okay, so your reference angle is going to be less than 90 degrees. Okay, less than 90 degrees. All right, that's all I have for you. Ta-ta for now.